Welcome to Pre-Technical Mathematics. This is a video lecture about the real number system, Chapter 1, Section 1. At any time, pause the video or stop the video to review the material in more detail. Let's get started talking about the number system. This should be pretty much of a review for you, but we'll refresh your memories and let's get us going. First, we'll talk about an integer. An integer can be negative, -3, -2, -1. It includes 0, and then also positive, but they are not fractional numbers, they are whole numbers. That is an integer. A rational number is the division of one integer over another. Again, they can be negative, such as -2/3, or they can be positive, such as 2/5. This is a rational number. An irrational number includes the radical sign, such as the square root of 2 or the square root of 5 or the third root of 10. Anything with the radical sign is an irrational number. Now, real numbers. What's a real number? A real number is both the rational numbers and the irrational numbers. Those are real numbers. And a decimal number we should be pretty familiar with working with. We'll put one down here, 3.250. It includes a decimal point. And we know that this is fractions of a hundred or thousands. Absolute values. This is distance from a number. The number is from 0. So we include these straight lines, which are the absolute value signs. And the absolute value is equal to the distance this number is from 0. So we essentially ignore the negative sign, and the value of this is 5. Place value, equal to the base of the number system raised to a power. Well, what that means is that we'll be talking about the tens column, the thousandths columns, and so forth. We'll get into those in a little bit. Rounding off numbers to a place value. We'll get into that in a little bit, and I think it'll be clearer when we start with some of the examples. So let's get started. Here's our first problem. -2/3. Now we want to look back and we want to decide what type of a number is -2/3. Well, first we know it's a rational, right? Because there's no radical sign, so it's a rational number. Also, if it's a rational number, it's also in the real number system. Okay, just to get you a little feel for that. Okay, now here's where we're going to start talking about values, place values. This is to the tens. We want this number rewritten to the tens columns. Okay, first we have to define what that is. This is the unit, or the ones column. This is the tens column. We'll put that down. This we know as the hundreds column. Now be careful that we don't use the TH because that's below the decimal point. Right now we're just going up. Unit, tens, hundreds, and what is this one? We know that as thousands. So if we're going to round 2,461 to the tens, we determine that the tens is the 6, and we look at the next number beside it. If it is 5 or more, we round up. If it is less than 5, we round down. So we make this into a 0, and we find that 2,461 rounded to the tens is actually 2,460. That is rounded to the tens. Get the idea? Okay, let's go on. Let's see what we've got next. Okay, in this case we're going to the 10,000s. So let's take a look at these again. This is the unit. This is the tens. This is the hundreds. This we know as the thousands. This one is the 10,000. So we're going all the way up here. And this one is the 100,000s. So our job is to go to the 10,000s. That's right here. We look at the number below it, and it's 2. That's less than 5. So we would keep the 10,000s number the same, and our answer would be, we turn everything below that into zeros, 430,000. Okay. When the problems are highlighted in blue, that means that's a problem for you to try on your own. So stop the video or pause it and try this problem on your own. The answers will be in the information block, the information tab on the main screen. So once you've done these, you can take a look and compare your answers. So take just a few minutes and do this problem. Okay, try this one. Pause the video if you need to. All right, let's go on. Now what we're looking at is an absolute value. These are the absolute value signs. And remember, we ignore the negative sign here. We just take the absolute value, or the number it is, from 0 on a number line. So we can simply rewrite this as square root of 7 over 8. And that is our answer. Here's our next problem. 2.5. This is representative of a decimal number. And we know if we were to look at that, let's see if I can draw a straight line. Not too bad. We'll label this as 0. This as 1. This as 2. And this as 3. Okay, so 2.5 would be right in the middle there. 2.5. That is our decimal value. Okay. This next one is to determine which is larger than the other. We'll use our greater than and less than symbols. Again, you should be familiar with this, but we'll get our brains working. So 9 is certainly greater than -7. Okay, let's try that with a little bit harder one. -7/2 and -8/3. We have to determine which is greater. In order to do that, we have to change these numbers into equal fractions. And we do that using the LCD, or least common denominator. Remember that? Our least common denominator between 2 and 3 is 6. So to make 2 into a 6, we need to multiply the top by 3. To make 3 into a 6, we need to multiply by 2. So we'll rewrite these. -7 times 3 is -21 over 6. -8 times 2 is -16 over 6. So now we have something that we can really compare it to. And -21 is less than -16. All right? Try this one on your own. Should be fairly simple for you. Check your answers in the Information tab. Try this one. Now what you'll notice there is the absolute value signs. Don't forget that. Okay, we want to go a little bit further in this section and talk about the properties of real numbers. Now you'll need to pause the video and really look at these in order to see what they're doing. We have the main ones. The first one, a plus b equals b plus a. That means you can change around the order of the numbers and it really stays equal to each other. That's the commutative property for addition. You can do the same thing with multiplication. Interchange the numbers. That's the commutative property for multiplication. Now here we refer to the grouping of the numbers. We can group A plus B and then add C. That'll be equal to A plus the group B plus C. We can really group any two numbers, and they are equal. That is the associative property for addition. It's the same thing for multiplication. We can group any two numbers out of the three, and they remain equal. The associative property for multiplication. Now we get down to an important one, the distributive property for multiplication. This says that this number on the outside can be multiplied by both numbers inside and still be equal. So you see you have the A times the B right there, and the A times the C. This becomes very important when you have a negative number out here, because you'll also multiply that negative sign inside parentheses. This is the distributive property for multiplication. Then we have a few identities. B plus 0 equals B. We know that if we add 0 to anything, it still remains the same. The identity element for multiplication is 1. B times 1, or anything times 1, is equal to B. Multiplying by 1 does not change the number. And then the inverse element for addition. The inverse element for addition is the negative number of the first. Take a number, let's say 3. You must add the inverse element, which is negative 3, in order to get 0. Now the inverse element for multiplication is referred to as the reciprocal. So we have 1 over b. If b is not equal to 0, we have to put that in there because remember, you can never divide by 0. Since b times 1 over b equals 1, let's write that out. B times 1 over b, we know, equals 1. That's the inverse element, or known as the reciprocal. Okay, here is our first problem with our properties. What we have is 8 times the group 4 times 6 equals the group A times 4 times 6. And what did we say that was? The associative. The associative property for multiplication. Regrouping the numbers still allows them to be equal. Let's take a look at this one. 3/16 by 16 over 3 equals 1. What did we say this was? It's the opposite of this, so it's the reciprocal, isn't it? And this property is the multiplicative inverse property. Okay, now we're going to reverse it. We now want to know the additive inverse of -8. We know that the additive inverse of a number has to equal 0. So what do we have to add to negative 8? 8. This is our additive inverse. What about our multiplicative inverse of negative 5? Again, we have to remember that our multiplicative inverse equals 1. So we have negative 5 and we multiply by that reciprocal again. 1/5. And as long as that equals 1, this is our multiplicative inverse, negative 1/5. Oh, now we changed it around a little bit, and we finally introduced that word that I've given to you a while ago, the reciprocal. That's the same thing as the inverse. So the reciprocal would be 2/1. The reciprocal of that. Okay, let's give you a few. I think you've got the idea. Take a look at this problem and tell me what property is used here. Remember, you can pause or stop the video in order to have more time. Here's another one. What property is used here? What is the additive inverse of 1/3? The additive inverse. What is the multiplicative inverse of negative 3/7? And what is the reciprocal of negative 2/pi? You do not have to change pi into a number. You can simply leave it as pi. Okay, the answers to these problems are found under the Course Information tab on your main screen. That's the end of this video.